Good morning. One of the things that people struggle with in any algebra class is simplifying square roots. So I want to go over that again today. It was one of the things that was missed a little bit more on the prerequisite unit summer homework thing. So I want to go over a few basic ones today. Today will all be square roots. Tomorrow we'll move into other roots and talk about how math is consistent. And then we'll move on to some other things. So here we go. If you look at the 6 examples I've written down for you, these are probably things you're going to want to write down somewhere in a notebook. We need to simplify square roots. Now that means leaving them in simplified radical form. We don't just punch into our calculator and get a decimal. Decimals are approximations. Square roots are exact values because they're irrational numbers. So if I, for example, look at the square root of 300, I know in the past, when you were younger, you would break that down into like a factor tree and circle all the groups of 2 and bring that out. What I want you to be able to do in Algebra 2 and Algebra 2 Trig is to be more efficient about that. What I want you to do is think about all of your perfect squares in this case, because these are square roots, and figure out what the largest perfect square is that divides into it nicely. And then rewrite it as a multiplication problem instead of doing all the big string of 2's or whatever it is that divides into your number nicely. Here's what I mean. If you look at the square root of 300, I know that the largest perfect square number that divides into 300 nicely is 100. So I'm going to rewrite the square root of 300 as the square root of 100 times the square root of 3. Well, the square root of 100 is a perfect square. The square root of 100 is 10, so I simplify that. The square root of 3 has to stay put, so 10 root 3 is my simplified answer. And again, knowing how to do it that way without writing out the big long string of prime factors is a lot more efficient, and we have bigger things to do with our time than to waste our time writing it out like that. Okay, so let's just do a couple more so I can highlight a few different things for you. The square root of 32 is very much like this. 8 times 4 is 32, but that wouldn't, 8 or 4 isn't the biggest perfect square number that divides into it nicely. Actually 16 is. So 32 is 16 times 2. Well, the square root of 16 is 4. You can't simplify the square root of 2, so you leave that alone. One of the things that makes students nervous a lot are fractions. In general, but especially under square roots. Well, fractions mean division, so you can break this up, the square root of 8/9 as the square root of 8 over the square root of 9. And we know the square root of 9, that's 3. So I'm going to simplify that right away, and it makes me feel a lot better. 8 is not a perfect square, but 4 divides into it nicely. So I'm going to rename that square root of 4 times the square root of 2, and then I can simplify. So in the end, my answer, square root of 4 is 2, leave square root of 2 alone, and leave that 3 on the bottom. So your answer is 2 root 2 over 3. Some of you may like to write that as 2/3 times the square root of 2. That's perfectly okay as well. Okay, another thing that makes students nervous are variables under our square roots. And the best and quickest way to think about those is any even number exponent is a perfect square. So essentially, if you have an odd number exponent, subtract 1 from it to make it even, and then go from there. Here's what I mean. If you take the square root of x to the 5th, I'm going to subtract 1 from 5, and rename this x to the 4th times x. X to the 4th times x to the 1st, we just don't write that, is x to the 5th. Sorry, I don't know how to make that go away. Okay. Now, here I have a perfect square. If you divide that, because this is a square root, divide your even exponent by 2, and that gives you the square root of it. So the square root of x to the 4th is x squared. Leave the square root of x alone. Okay, sometimes you have more than one variable. Same idea. A to the 3rd, well, that's odd. 3 minus 1 is 2, so I can rename this as a squared times a. B is going to have to stay inside because that's just b to the 1st. It's not a perfect square and can't be broken into 1. Square root of a squared. 2 divided by 2 is 1, so an a comes out, and this a has to stay inside the little square root, so does the b. So my answer is a times the square root of a times b. And then to make matters worse, we can combine numbers and letters. I always suggest that you just break it up and see how it goes. So here we go. Square root of 18, I'm going to bring out square root of a squared and square root of b to the 7th. And I'm going to think about each piece separately. Well, 18, the largest perfect square number that divides into 18 is 9. So this is the square root of 9 times the square root of 2. A squared, that's an even numbered exponent. That's perfect. The square root of a squared, 2 divided by 2 is 1, so that is just a. The square root of b to the 7th, well, that's odd, so I can subtract 1 from it to make it even. So I'm going to rename this the square root of b to the 6th times the square root of b. Now let's simplify what we can. Square root of 9 is 3. Square root of 2 has to stay put. A is hanging out outside. The square root of b to the 6th, 6 divided by 2 is 3, so it's b cubed. And the square root of b will have to stay inside. Now finally, you want to clean it up. You want to bring all of your non-irrational numbers out front and leave your irrational numbers all under one square root. So 3 is out front, a is out front, b cubed is out front. Square root of 2 and square root of b cannot be simplified, so they both stay under the square root together. And there you go. So do some practice problems, and we'll certainly review anything that you have questions on in class tomorrow. Thanks. Have a great afternoon.